Hello, I'm Ken Hudson. I'm a graduate student at UCLA in the Department of Civil and Environmental Engineering, and I'm going to talk to you guys today about the interpolation of ground motion intensity measures using kriging at liquefaction sites. So it's important, especially in the next generation liquefaction project that I'm involved in, to get accurate estimates of ground motion intensity measures at liquefaction sites. Now, this is really important because it forms the demand side of the equation for models like triggering models and manifestation models that we're trying to regress from our data sets that we have in the NGL database. So we wanted to come up with a way to more accurately estimate the intensity measures at each of these liquefaction case study locations. So we've come up with the following workflow to do so. First, we estimate the intensity measures at the recording stations that we have using ground motion models. So an earthquake occurs, it records at recording stations different intensity measures, and we have those values, and now we come back and we compute the estimated intensity measures using a ground motion model or multiple ground motion models of our choice that are fitting for the region. Next, we will compute the residuals of those intensity measures based on those estimated values and the recorded intensity measures at those stations. And the residual R total can be broken up into the event term eta E and the within event residuals delta W, shown in the equation there. And that total residual is just the difference between the intensity measures in natural log units. Next, we compute an empirical variogram from that spatial data, and we fit a variogram model to it. From that variogram model, we can generate a residual Krig. And the final step then is to look at the liquefaction sites that we're interested in, compute the estimate of the intensity measure using the same ground motion models we started out with, and then querying that residual Krig at those liquefaction sites and modifying the estimated intensity measures using the Krig queried residual to get a final intensity measure estimate. So I'm going to go through an example using the Loma Prieta earthquake. Here is a satellite image showing that 1989 fault rupture in red. The recording stations where we have the intensity measures recorded are shown in yellow triangles, and the blue NGL sites where we have liquefaction or no liquefaction observations along with geotechnical subsurface data are located. Those NGL sites often do not correspond with where we have recording stations, which is why this interpolation step is so important. Here we are showing the recorded intensity measure in blue, the estimated intensity measure using the Bohr, Stewart, Sahon, and Atkinson 2014 ground motion model from the NGA West 2 project in orange. And then in green, we're adjusting those orange estimates by the computed event term, which is taken as the average of the total residuals. On the right, you can see the within event residuals plotted using that heat map scale at each of the recording stations. And so you can see in the Bay Area, San Francisco, and Oakland, there's very high residuals around 1 or higher. And elsewhere, they're either around 0 or negative, depending on the location. Next, we compute the imperial variogram from that data set, and we fit a variogram model, such as this stable variogram, to the data set. Then we need to compute the within event residual Krig from that data. What is shown on the left is that Krig with the stations with the recordings overlaid on top of it with the same color scale applied. And on the right is the same Krig with the same color scale showing the within event residuals along with the NGL sites and their interpolated residual at each of those locations. Then at each of those locations, we can compute that same BSSA intensity measure estimate, and taking the Krig's residual interpolation, we can adjust that intensity measure to what is shown on the right in those heat maps. The color scale is the same on both the left and the right. On the bottom, you can see as a function of distance how the PGA changes.